So to start with, uh, let's go through the question once and we'll see how each and every line is conveying us certain information. An airport has recently introduced a driverless pod system to transport passengers between the terminal and the car park. Pods operate every 2 minutes from the terminal exit, and each pod can take up to two passengers and their luggage. Passengers arrive at the terminal exit seeking to travel to the car park according to a Poisson process with a rate of 1 per minute. If four or more passengers are waiting at the exit when a pod arrives, taxis are immediately summoned to take all the remaining passengers to the car park. So the first sentence is basically telling us that recently a driverless pod system has been introduced so as to transport passengers. Then pods are operating every 2 minutes from the terminal exit, and each of them can carry up to two passengers and their luggage. Now, passengers are arriving at the terminal according to a Poisson process with a rate of 1 per minute. So far, what we know is pods operate every 2 minutes. They can carry two passengers at a time. Passengers are arriving at the terminal exit according to a Poisson process with rate 1 per minute. And then further, we have been given that if four or more passengers are waiting at the exit when a pod arrives, this is extremely important. This particular part, if four or more passengers are waiting at the exit when a pod arrives, taxis are immediately summoned to take all the remaining passengers to the car park. Why I'm emphasizing on this particular term that when a pod arrives is because this will help us in part two to basically model what possible states state space would be there and how exactly this particular modeling is going to work. So as with any markov chain, the most critical part is to understand what we are trying to model. That is the most critical part. Next is key, what would be the states that will help us to model it, and then obviously the one step probabilities. So in this question, most of you would have faced issues here in all these 3 points. First part basically asks us to calculate the probabilities that 0, 1, 2, 3, and 4 or more passengers will appear at the exit to the terminal in any given 2 minute period. So we know that passengers are arriving at a rate of 1 per minute. So in 2 minutes, the rate will be nothing but a rate of 2. That is the first key point to understand is that the rate has been given to be 1 per minute. If I want to work in a period of 2 minutes, in that case, the rate shall be 2 per 2 minutes. So this is something part one which can be easily calculated. I'll yet do it for the sake of completeness of this question. We would be working for a 2 minute time period. So all my uh, random variables are for basically a 2 minute time period. So let us denote this by n. N follows nothing but Poisson 2. So we need to find probability n equal to 0, probability n equal to 1, probability n equal to 2, probability n equal to 3, and probability n equal to, in the question, just let me see whether they're asking 4 or 4 plus. So they're asking 4 or more. So this is basically n greater than equal to 4. This will be e to the power minus 2. This shall be 2 e to the power minus 2. This shall again be 2 e to the power minus 2. This shall be 4 by 3 e to the power minus 2. And this can be written as simply 1 minus the addition of all these 4, which will basically come out to be 16 by 3. If I'm no, this is 5, 19 by 3 e to the power minus 2. So this is direct formulas which you can put and you'll find that the answers are coming in this form exactly. So probability n greater than equal to 4 will be nothing but 1 minus 19 by 3 e to the power minus 2. So let me just compute the numerical values as well, just to cross check it. First we have shift e to the power minus 2. just taking it till let's say three decimal places, 0.135. This shall be 0.27. This shall also be 0.27, and this shall be 4 divided by 3, 0.180. So 0.54, 0.72, 0.855. This shall be something 0.145. Yes, this shall be 0.145. So these are the set of probabilities which we have to calculate. Now again, going back to the question. Acha, before going back to the more important part, second part, does anyone of you have doubt in this first part so far? Again, I'm just assuming that this paper is coming in, let's say, paper A exam. So not going into the R code and how it needs to be done. That is something, in case you have doubt, you can just reach out to Gunjan. As for, say, solving it on paper A, this is how we shall be proceeding. So any doubt in this particular part, kindly mention a yes or a no in the chat box. If not, then I'll proceed to the second part. Okay, no doubts. Fine. Next is determine a transition matrix for the number of passengers waiting at the exit when a pod arrives. So here my time step is going to be when a particular pod arrives. And the pods operate every 2 minutes. So basically one step here will be nothing but 2 minutes. That is what my one step is going to be here. So now we need to determine the transition matrix of the number of passengers waiting at the exit when a pod arrives. So before divulging the solution, make any guess. You can put it in the chat box, or you can even unmute yourself and go ahead. What do you think? What would be the possible state space? What would be the possible state space? What we are trying to model is the number of passengers waiting at the exit when a pod arrives. So
It
what
could be,
could, yes, go ahead.
yeah, it could be 0. It will be 0, 1, 2, 3, and 4 plus. So 5
Is
states.
okay. One of you is saying it will be 0, 1, 2, 3, 4 plus. Okay. We could also model it this way: 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Any reason why you're leaving it till 4 plus itself?
Yeah, because if it is 4 plus when a pod arrives, so
Hmm.
everybody is going away. So once it is 4 plus, it's as good as 0 again, because taxis are coming and taking everyone away to the terminal
That
or
is
to the
fine.
car park.
I'm just trying to ask, I mean, assuming that you haven't gone through the solution, shouldn't the first thing come to mind is this, that number of passengers waiting, they could be four, they could be five, they could be six. Any particular reason for clubbing it all under 4 plus? If you have taken a look at the answer, then that's a different thing. Then you already know what you need to do. But ideally, I guess most of you would have this in mind. It could be 0, 1, 2, 3, 4, 5, 6, 7, so on. It could be anything. The question only asks the number of passengers waiting at the exit when a pod arrives. So when a pod arrives, it could be, let's say, 2, it could be 4, it could be 40 as well. So clubbing it under 4 plus is something which we would be doing, but it's more about the first time, looking at this question. So why directly 4 plus? Why not, let's say, 4, 5, 6, 7, so on? We'll see later why we can combine it. The reason which you mentioned was not exactly correct, that all of them would be taken away. Fine, all of them would be taken away, but the fact is, if you're trying to model the number of passengers waiting at the exit, it actually can be 5, 6, 7, 8, so on. We could model that way, only that that modeling exercise will be a bit more complex, and an easier exercise can be done with a lower number of states as well. Anybody else? Any other thing which you might have felt it's fine if you'll go wrong. It's just about to know once you read the question, what exactly do you get out of it? What could be the possible states.
So, sir, this might not be a like a very according to the concept, but in the first part they have asked us to calculate the probabilities for 0, 1, 2, 3, and 4 plus. So, like from there, I took a hint that it should be that would be the state space.
Okay.
Yes,
Uh,
yes.
Kind of fine, makes sense. You're using certain information or certain information provided in the earlier parts of the question, so that still makes sense. Okay. Anybody else? Anything else apart from the usual 0, 1, 2, 3, and 4 plus? Okay, fine. Okay, the state space are gonna be 0, 1, 2, 3, and 4 plus. Okay, let's go back to sharing my screen. Just a second.
Sir,
Yes.
like I think it should be like 0, 1, 2, 3, 4, 5, and more also now, because like you mentioned that the question is about when the pod arrives. Taxis are
Okay.
some after the pod leaves and if number of passengers are left, right?
If number of passengers are
Like if number of passengers are four or more, then
hmm,
first the pod arrives, then it takes the passengers, and the remaining passengers are then taken by the taxi, right?
no, that is not how it's working. So, how this is working is that when a particular pod arrives, if they see four or more passengers waiting, immediately a taxi is summoned and the taxi carries all these passengers, whether it's four, whether it's six, whether it's 10. So, that particular pod is not carrying any passengers as such. And anyway, whether that pod is carrying or not, it will not make a difference because what we are trying to model is the number of passengers waiting when a pod arrives. So let's say the first pod arrives, okay. There are more than four passengers waiting. So all of them would be leaving. Whether they leave through a taxi or a pod again doesn't matter. Next time the pod comes, we would now be interested ki how many more passengers are there. So even if you have this doubt, whether the pod will be taking two passengers and the rest would be taken by taxi or all of them would be taken by taxi, it will not make an impact here because it doesn't matter because once a pod comes, how things go ahead doesn't matter. The next time when we observe the process is when the next particular pod arrives. So whether they leave through a taxi or they leave through a pod, it doesn't really matter because either way they are leaving the particular exit.
We can take 5, 6, 7 also, but it
Yes,
will
we
lead
can.
to the same probabilities again. So the last three rows and the last three columns will be the same.
Yes, that is what we are going to do. As I said, to simplify our modeling exercise, we can combine all these states 4, 5, 6, 7, 8 into 4 plus itself. Again, a more, as in, might be you might have also got this particular hint only that in the first part they have asked us to calculate such probabilities. So from there you can take some hint, but again, this is something which will not be, something you can extend it to all other questions. Here it is. We'll see that the first part is completely different than what we're trying to do here when it comes to getting probabilities. State space, yes, it's coming out to be same as well. That is 0, 1, 2, 3, 4 plus, but the reason is slightly different. So for the timing, to instead of writing the numbers, I am just denoting the probabilities as A, B, C, D, and D, where A is probability that zero passengers are arriving in a 2 minute period. B is that one passenger is arriving. C is 2, D is 3, and E is 4 and greater than 4. So now coming to the state space 0, 1, 2, 3, 4 plus 0, 1, 2, 3, 4 plus. So now first try to understand ki here what exactly is time. State space we have understood. Next time is to understand the concept of time. So here time is nothing but when each pod comes. So say my first time period will be nothing but my when my first pod is coming. The next time at which the process shall be observed is when the second pod coming, and then the third pod, and then the fourth pod, and so on. So these are nothing but for a 2 minute time period. And in part one, we have calculated the probabilities of passenger arriving in a 2 minute time period itself. Had it been some other time period, 1 minute, 3 minute, so again we would have to calculate probabilities for this part as well. But because in part one we have already calculated probabilities for a 2 minute time period, so that is something which is consistent with the time step which we are going to use in this particular part as well. So now just try to see how it's going to work. This particular state 0, this basically means that when the last pod came, okay, there were 0 passengers waiting. Now tell me, what are the possible cases that can happen when the next pod comes? How many passengers can be there? What can be the possible values? I'm just again repeating, this 0 represents that when the last pod had come, there were 0 passengers waiting. Now, when the next pod comes, what are what all are the possible cases? How many passengers can be waiting at the exit?
Any number 0 to n, 0 to 4 plus, 0 to 5, 6, 7, 8, 0, 1, 2,
Okay,
3,
so
4,
basically
5,
it
6,
could
7,
be
8.
any number, any
Yeah.
non-negative integer, 0, 1, 2, so on. Okay. Another one of you commented that any number from 0. That is slightly a wrong way. I mean, a better way would be any integer starting from 0. Any number from 0 means it could be 0, 0 0.1, 0 0.2 as well. So that is just something technicality. So it could be any, let's say, non-negative integer. That is what two of you have put in. What about the rest? What about the rest? Okay. So yes, exactly. We can get 0 passengers, 1 passenger, 2 passenger, 3, 4, 5, so on, anything. So 0 passengers is here. When the next pod arrives, 0 passengers are there. So what it means is that in the next 2 minute time period, how many passengers have arrived? 0 passengers. The probability of that is nothing but given to be A itself. The probability of that is nothing but given to be A. That is probability n equal to 0. Similarly, if I want to be in this particular state, that is 1 passenger is waiting when the next pod arrives. It means that in the last 2 minutes, exactly 1 passenger has arrived at the terminal exit. The probability of this is B. Similarly, 2 it is C, 3 it is D, and for 4 plus it is nothing but E. Now suppose 1 passenger was waiting. Okay, 1 passenger was waiting when that particular pod arrived. Now, please try to understand, this is the critical part. 1 passenger was waiting when the last pod had arrived. So that particular pod would have taken this 1 passenger. So this 1 passenger was there when the pod arrived. This was there when the pod arrived. And this pod will be taking this particular passenger. So it will become 0. Now when the next pod arrives, okay, so how this 0 can be there? If 0 passengers were there, if 0 passengers arrived in the next 2 minutes, the probability of it is again A. How will 1 passenger be there? If in the last 2 minutes exactly 1 passenger has arrived, the probability of which is B, and similarly C, D, and D. Please let me know if this makes sense or not.
Sir, can you please explain again the one?
So what we are trying to model is the number of passengers when each pod arrives. Okay. So suppose 1 passenger was waiting at the airport or at the exit when a pod arrived. So this is this case 1. Now when this pod arrives, 1 was waiting and then this pod takes this 1 passenger away. So immediately after the pod arrived, from 1 it becomes 0. Now to check when the next pod arrives, I have 0 passengers waiting. This is equivalent to that in the 2-minute time period, 0 passengers would be arriving at the terminal exit. What you need to understand it here, it is one, as soon as the pod arrives, this particular passenger is being taken by the pod, and so it becomes 0. And now again, to work with the probabilities, we need to see 0 is the starting point. End point could be 0, 1, 2, 3, or 4 plus.
Sir, I'm not so clear about this part. Like I'm getting confused if we are taking into consideration the previous pod.
The last pod had come, okay. The last pod came, it saw one passenger was there. We observed one passenger. Now that pod will be taking away that one passenger as well. That passenger won't be staying there now. It would be going with the pod, right?
Yes.
So it becomes 0 at the last pod itself, right?
Yes.
So now to check how many passengers are waiting there for the next pod, my reference point will be 0 only, right? That one passenger had already left when that pod had arrived.
But sir, if suppose there are three passengers waiting when the
We'll
last
come to 3 passengers. Right now we are in 1 passenger. We'll come to 2, 3, 4. Right now there is only 1 passenger. So that 1 passenger goes away. So 0 are left behind. Now in the next 2 minutes, what will happen is going to determine how many passengers are there when the next pod arrives.
No, but so like what I was saying is, okay, if there suppose before the arrival of last pod, if there were three passengers and when it
Again,
departed,
I'll come to that one, 3 passengers. Right now I am telling you there is only 1 passenger. So now you try to visualize in your head. Okay, think it maybe to you're from Mumbai. I'm not sure there the normal auto system like we have in Calcutta, the shuttle system, it applies or not. Let's take an example of, let's say, a bus system wherein a bus will take in a maximum of, let's say, 20 passengers. Okay, so let's say you're standing in a bus line. Okay, when a bus comes, suppose one passenger was waiting. Just next second, that one passenger would have left in the bus. So there are 0 passengers waiting in the bus line. Now the next bus will arrive after 2 minutes. So now I need to check in those 2 minutes how many passengers would be there. And that first passenger, that one passenger which was there, it doesn't make any difference because that passenger has left in the bus.
okay, correct, got
What
it.
we are trying to observe is when the pod comes, just before that, how many passengers are there. And you need to keep in mind when the pod goes away, it will take certain number of passengers with itself, which is obviously maximum of 2. So when you will take the case of 3, 4 plus, we'll see how that is going to work. We'll come to that. Right now, is this clear to everyone? I won't repeat towards the end of the class. If it's not clear, ask me right now itself whether this is making sense or not. What I'm trying to say is the most important part is we are observing the process when a pod arrives. So we need to look at the passengers just when the pod arrives. And as soon as the pod leaves, the number of passengers waiting there will decrease. But we do not have to observe that. What we have to observe is the passengers that are waiting when a pod arrives.
Sir, just for further clarification, this the ones mentioned in the call as the row headings like 0, 1, 2, 3, 4 plus would be the number of passengers waiting at time n, and this mentioned as the column headers would be the number of passengers waiting at time n plus 1, correct?
Yes, yes. You want me to describe XN, number of passengers waiting at exit when, let's say, nth pod arrives. That would make more sense maybe when nth pod arrives. Others, is it clear what I'm trying to do here? and Ankita, Gara, Deepika, Kanishka, Khushi, Ronak, Sanskriti, Yuti. Is it clear, all of you, what is happening so far?
Yes, sir.
Okay. Now coming to the third case, when two passengers are waiting. Again, when two passengers are waiting and the pod arrived. Okay, so two are waiting. Now this pod will take both the passengers. So again, just after this pod departs, there are zero passengers waiting. So now if I want zero passengers to wait when the next pod arrives, it is equivalent to the fact that zero passengers come in the last 2 minutes at the particular exit, the probability of which is nothing but A. This will be B. Similarly, this will be C, D, and E. This is similar. If you have understood how this particular row is working, the second row, the third row is the similar case. The difference which will again come here will be in the third case, this particular row. So now suppose three passengers are waiting. Okay, three passengers are waiting. Three passengers are waiting when the pod arrives. So how many passengers will the pod take? It will take two passengers. So I'm left with one passenger. So if one passenger is waiting, even if no passengers come during the next 2 minutes, just a second, some of you are posting something on the chat. Ankita, you could maybe log out and log in again. Others, are you all able to hear me clearly, or is my voice breaking to any one of you?
Sir, it's clear for me.
Okay, I guess then Ankita, it's some internet issue on your part, so maybe you could try some other connection or just log out and log in again. Coming back to the question, so three passengers are there. Okay, when the pod comes, three of them are there. The pod takes away two. We are left with one. Now it is not possible only that when the next pod arrives, there would be zero passengers waiting because already one passenger was there from the last time. So this will be zero. This again, I'll keep on repeating for complete clarity. Three passengers were there when the last pod arrived. It took away two of them. One passenger was there. Now, how will I again have one passenger when the next pod arrives? If zero passengers are arriving at the exit, the probability of that is nothing but A. How will I have two? Two will be there if one passenger is arriving in the last 2 minutes, probability of which is B. How will I have three? If two passengers are arriving in the last 2 minutes, the probability of which is C. How will I have 4 plus? If three or more passengers are coming, the probability of which is D plus E. D is probability of three passengers, E is probability of four or more passengers. Now see whether this is making sense or not. Okay. I'll again repeat as one of you have asked. There were three passengers when the last pod arrived. It took two of them away. We were left with one. Okay. So first of all, I cannot have zero passengers when the next pod arrives because that one person is already there. Unless you assume that that one person goes away or something like that, which is a very bad assumption here. No need to make that assumption. This will be zero. How will it be one? How will it be one when the next pod arrives? If one was C, again, three was there. From three, we took one immediately. Now, again, I want one. So, how many passengers should come? Zero passengers. The probability of which is A. How will I have 3 to 1 to 2 if one passengers come? The probability of which is B. How will I have go from 3 to 1 to 3? If two passengers come, the probability of which is C. How will I go to from 3 to 1 to, let's say, 4 plus, if 3 plus comes? 3 plus can be written as 3 and 4 plus. Probability of 3 passengers arriving is B. Probability of 4 or more passengers arriving is E. So D plus E. Is this clear, Kanishka? Okay. Now coming to 4 plus. Now again try to understand this how it's going to work. As for 4 plus, okay, a pod arrives, it sees that 4 plus passengers are there. Immediately a taxi will be summoned, and all these four of them, or more, however how many are there, 4, 5, 600,000, doesn't matter, all of them would be taken away. Whether it is through taxi or pod doesn't matter. Point is, zero would be waiting. So from 4 plus we directly go back to how many? 0. And so now again the probabilities will be nothing but A, B, C, D, and E. See if this is making sense or not. If 4 or more than 4 passengers are waiting, when a pod arrives, all of them are immediately taken away. Now, whether that particular pod takes away, whether that taxi takes away, is not going to influence anything, because the next time the pod comes, or rather, should I say, the moment that particular pod leaves, there would be 0 passengers waiting at the exit. And so the probabilities would be similar, as you will see in the case of 0, 1, 2, or 4 plus. The pod arrived, there were different passengers, but as soon as that particular pod leaves, they're left with how many? 0 passengers. So the development will be at a similar pace. So this becomes A, B, C, D, E. So this is basically the transition matrix for this particular process. Is this clear? Again, after this class, maybe go back again, give it a try yourself, try to note it down in the notebook and see how it works. Perfect then. So that was it regarding this particular question.